In this video, we are going to talk about this past paper 2012, question number 25. Before we move on, remember that you should have gone through the learning video. In that video, you have learned how to perform the step 1 and step 2 so that you can carry out similar procedures for this past paper. Let's begin. For the first step, we just need to trace them into individual straight lines. So we consider the slope by using the slope-intercept form. Quickly, we can also do the same for L2. And then, from the slope-intercept form, we know that the slope for L1 is negative a. From the diagram, the inclination tells you that the slope is greater than 0. Therefore, we can deduce that a is smaller than 0. Similarly, for L2, the slope is negative c, and then it is greater than 0, so we can deduce that c is smaller than 0. For the y-intercept, we put x by 0, therefore the y-intercept for L1 is b. From the cutting point on the y-axis, we know that the y-intercept should be greater than 0, therefore b is greater than 0. Similarly, for L2, the y-intercept is d, and then the cutting point is below x-axis, so we know d is smaller than 0. For the x-intercept, we can find by putting y by 0. For L1, the x-intercept is b over a. From the diagram, we know that the x-intercept is smaller than 0. However, we have found out the range for a and b already. Therefore, this inequality, we don't need to use it. We just need to know how to find the x-intercept. For L2, the x-intercept is d over c and greater than 0. Once again, this inequality is not needed. For step 2, we need to compare the slopes. From the diagram, we know that the slope of L2 is greater than the slope of L1. We copy the slope from above, so negative c should be greater than negative a. We multiply by negative 1 on both sides, we will get c is smaller than a. And then we compare the y-intercepts. From the diagram, you can see that the cutting point of L1 is higher than L2. Therefore, y2 should be smaller than y1. We copy the y-intercepts and we will know d is smaller than b. But actually, this result is too obvious as d is smaller than 0 and b is greater than 0. Anyway, we can find it by comparing the y-intercepts. Finally, we compare the x-intercepts. From the diagram, you can see that the cutting point of L2 is on the right-hand side of L1. Therefore, x2 should be greater than x1. We copy the x-intercepts from above. D over c should be greater than b over a. This one's a little bit more complicated, so be careful. First of all, we multiply c to both sides. And remember, you need to check the sign of c. From above, you know that c is smaller than 0. If you multiply a negative number, it will change the sign. So d is now smaller than b times c over a. Finally, we move the a to the other side. And we need to check the sign of a. A is smaller than 0 again. So if you multiply a to both sides, it will change the sign again. Finally, the result should be a times d is greater than b times c. Just repeat these steps and you can always solve similar problems. Hope you like this video.